I want to take a look at a problem that was surprisingly difficult for Chat GPT. I tried to solve this problem using Chat GPT and it simply couldn't do it after being given so many hints and being guided in so many ways. So we want to see what the problem is about. So we begin by greeting our friend Chat GPT. Hi, friend. And Chat GPT responds, hello, how can I assist you today? And then we have the question. I have 32 bills in my wallet in the denominations of $1, $5, and $10, and it's worth $100 in total. The question is, how many do I have of each denomination? So we have three denominations: $1 bills, $5 bills, and $10 bills. And we know the total amount we have is $100. So we want to know how many of each denomination we have. So ChatGPT begins to solve the problem. It attempts to do it. It says, let's solve this problem together. Let's denote the number of $1 bills as X, the number of $5 bills as Y, and the number of $10 bills as Z. And so from the given information, we can set up the following equation. So goes ahead to set up two equations: 1x plus 5y plus 10z equals 100. That's correct. And then x plus y plus z is equal to 32. That's also right. So it says now we can solve these equations simultaneously to find the values of x, y, and z. And first, it wants to rewrite the second equation in terms of z. And it does that correctly. And then it substitutes that into the first equation so that we get x plus 5y plus 10z, but z is now 32 minus x minus y. That's equal to 100. And then goes ahead to simplify, does the simplification correctly, and we end up with this equation: 9x plus 5y equals 220. So now we have a system of equations. We have 9x plus 5y is 220, which is what we just found. And then we have x plus y equals 32. Now that is a surprising result right there. X plus y equals 32. You wonder where ChatGPT got that from, because we don't have that anywhere. What we have is x plus y plus z equals 32. So maybe this is where things begin to go wrong. But let's continue. It says we can solve the system using various methods such as substitution, elimination, or matrix operations. And it says, okay, let's use the elimination method. So we multiply the second equation by 9. Now, bear in mind that this second equation was problematic. So if you're multiplying by 9 and then doing something with that, we should expect to end up in some trouble. But let's go ahead. So multiplies that equation by 9 and gets this result. That's okay, assuming that equation is correct. And then so we now have these two equations, and then he wants to subtract the first from the second, and goes ahead to do that, and we get y equals 17. And then he substitutes the value of y back into the second equation to get x equals 15. So this is the equation he's using: x plus y equals 32. And that's what's leading to so much trouble, because now he's completely thrown out z. Then it says now we have the values of x and y. Let's substitute these into the first equation to find z. And he substitutes x and y into a certain equation: 9x plus 5y equals 220. But there's no z in that equation. He himself threw out the z in that equation. That is this one again. So he shouldn't expect to find z with that substitution. But then he goes ahead to conclude that therefore we have found that x equals 15, y equals 17 and z equals 32 minus x minus y, which is 0. So 15, 17, and 0. And then it says, so I have 15 $1 bills, 17 $5 bills, and no $10 bills in my wallet. That is his final answer. But then I reply with, is there only one answer? And then ChatGPT comes back with, oh, apologies for the confusion in my previous response. You're right. There are multiple possible answers to this problem. Let's consider the problem and explore all the potential solutions. So this response says that ChatGPT thinks it's done something wrong, acknowledges that it's done something wrong. So it's going to do better this time. So let's see how exactly he's going to do better. All right. So we have, it says, let's denote the number of $1 bills as X, the number of $5 bills as Y, and the number of $10 bills as Z. So this is the same as in the first approach he used. And then he gets these two equations, same as before. And then he says, for all possible solutions, we can use trial and error or systematic enumeration. And he says one approach is to start with one variable and solve for the other two. So let's assume Z, that's the number of $10 bills, is 0. So here, there's a suggestion that he's going to try to do some systematic uh, enumeration. He's going to try with 0, then maybe with 1, then 2, then 3, and then see where that takes him. So from the equation x plus y plus z equals 32, he gets x plus y plus 0 equals 32, which simplifies to x plus y equals 32. So by assuming z is 0, this is what he ends up with. Now he says we should substitute this into the total value equation, which is this equation. So yes, if you substitute z equals 0 into that equation, this is what you get. So that reduces to x plus 5 equals 100. And then now he says we can try different values for y and solve for x. Now if we let y be 0, then x plus 5 times 0 equals 100, which implies that x is 100. So here we began by assuming that z was 0. And then the hope was that with that we could solve for x and y. But in solving for x and y, he makes another assumption that let y be 0. So two assumptions. If we let y be 0, then this is what we have. It means that x is 100. However, he says this violates the total number of bills equation, which is x plus y plus z equals 32, as the sum of x, y, and z should be 32. So the sum should be 32. So if you have only one of the values being 100 and they should all be positive, then you have some big trouble ahead of you. So he recognizes that and sees that that is not a viable solution. So he says if we let y be 1, then x plus 5 times 1 equals 100, which simplifies to x is 95. Again, this does not satisfy the total number of bills equation. So we can continue this process, incrementing y and solving for x until we find values that satisfy both equations. So he tries for y equals 2 and he gets x is 90. Now he checks it to see if this value satisfies the total number of bills equation, which um, he computes and sees that it doesn't satisfy. So that assumption also is flawed. Then it says we can continue this process until we find solutions that satisfy both equations. However, in this case, it seems that there is no combination of x, y, and z that satisfies both equations simultaneously. So ChatGPT reaches a surprising conclusion. After trying a few values, maybe one or two, he has given up and concludes that we there's no combination of x, y, and z that satisfies both equations simultaneously. And then he goes on to say, therefore, there might be an error in the problem statement, or a typo. So we either have an error or we have a typo in the values provided. Please double check the information given and let me know if you need further assistance. So this is ChatGPT's second attempt at the problem, and he still appears clueless. And so we try to give it a hint. I don't know if I should refer to it as it or him, but he's our friend, so we give him a hint. And it says, what if I must have at least one $10 bill? That is the hint. That you keep making the assumption that we should start with z equals 0, but you're not able to move on to z equals 1 and 2 and 3. So what if we say that, okay, you cannot use 0. You should have at least one $10 bill. Maybe that's going to make the problem easier. Let's see how it does with that information. Well, it says if you must have at least one $10 bill in your wallet, then we can modify the problem accordingly. Let's denote the number of $1 bills as X, the number of $5 bills as Y, the number of $10 bills as Z. Then we have the following equations. These are the same equations as before: the total value equation, the total number of bills equation, and then we have this extra condition that says Z is greater than or equal to 1. Now, to find the solutions, we can use a similar approach as before. Now, immediately we read something like this, we should be a little wary because that is the approach he's been using so far has not been helping. So let's see how it does this time. It says, let's consider Z, the number of $10 bills, as 1. So he assumes Z equals 1, no longer starting from 0. So that's a bit of an improvement. Then he says from the equation x plus y plus z equals 32, we have x plus y plus 1 equals 32, which simplifies to x plus y equals 31. That's correct. Now substitute this into the total value equation, and that gives us x plus 5y equals 90. Then he says again we can try different values for y and solve for x. So he tries to do that. He says if we let y be 0, then x is 90, which implies x is 90. However, this violates the total number of bills equation, okay, as the sum should be 32. If we let y be 1, then x plus 5 times 1 equals 90, which simplifies to x is 85. And he says this satisfies the total number of bills equation. Now, that is a surprising result, to say that having x be 85 satisfies the total number of bills equation. We know that the total number of bills is 32. So if you have, in that 32, it comprises x, y, and z, and all of these numbers are positive. So if you have only one of them being 85, that should ring a bell, but ChatGPT says that this satisfies the total number of bills equation. Okay, so for the condition of having at least one $10 bill, one possible solution is x equals 85, y is 1, and z is 1. This means you have 85 $1 bills, one $5 bill, and one $10 bill. It says, please note that there may be other possible solutions as well. You can explore different combinations of x, y, and z while ensuring that the conditions and equations are satisfied. Now, ChatGPT wasn't able to check its work, surprisingly, because if you have 85 $1 bills and one $5 bill and one $10 bill, then you have 87 bills and not 32. So that's a problem. All right, then we give ChatGPT another hint. It says, but that would mean I have more than 32 bills, no? I mean, if you're saying I have 185 $1 bills, one $5 bill, and one $10 bill, then I do not have 32 bills. I have way more than that. So ChatGPT comes back. He says, apologies for the oversight. You're correct. In the scenario where you must have at least one $10 bill, the solution I provided earlier validates the total number of bills equation. Okay, so he acknowledges his fault. Let's see if he's going to do better. He says, let's consider the problem with the requirement of having at least one $10 bill and a total of 32 bills. we have the following equations. So these are the usual equations that we had before. It says to find the solutions, we can use a systematic approach. Okay, since we have a constraint that z must be at least 1, let's start by assuming z equals 1. Okay, from the total number of bills equation, we have this. Yes, we've already done this. Now substituting this into the total value equation, we get that. Okay, now let's try different values for y and solve for x. So he goes ahead to do that and says if y is 0, then x plus 5 times 0 equals 90, which implies x is 90. However, this validates a total number of bills equation. Okay, so he's aware of this equation and he's able to detect when it's validated. Now, if y equals 1, then x plus 5 times 1 equals 90, which simplifies to x equals 85. And then, surprisingly, he concludes that this satisfies the total number of bills equation. I don't know why it keeps making this error. I mean, right before over here, it's able to identify that the total number of bills should be 32. And so when he got x equals 90, he immediately knew that he was wrong. But here, he gets x equals 85 and is not able to identify that because 85 is more than 32, that answer cannot be correct. He just goes ahead and says this satisfies the total number of bills equation. That is quite a surprise. Then he says, therefore, one possible solution with z equals 1 is x equals 85, y equals 1, z equals 1. This means that you would have 85 $1 bills, one $5 bill, and one $10 bill. This is the same answer he got as before, and it's wrong. And he's been prompted that it's wrong. He's apologized for being wrong, but he's repeated the same mistake. So this is pointing to a fundamental flaw in ChatGPT's ability to handle questions of this sort. He's saying in this case, it seems that there's only one possible solution that satisfies all the given conditions. Once again, I apologize for the confusion caused by the previous incorrect response, except that this is another incorrect response. Okay, so we give it another hint or another critique. So you still haven't solved the problem. ChatGPT, you still haven't solved the problem. Then he says, okay, apologies for the confusion caused earlier. Let's solve the problem correctly, considering the requirement of having at least one $10 bill and a total of 32 bills. Then he says, okay, we have the following conditions. So all these conditions are correct. Just to find the solutions, let's consider the constraint of z greater than or equal to 1 and the total number of bills equation. So if z equals 1, then x plus y plus 1 equals 32, which implies x plus y equals 31. Okay. Substituting this into the total value equation, we get this, which is also correct. Now let's try different values for y and solve for x. Then he says if y is 0, he's tried this before, ended up in a ditch. Here he concludes correctly that you cannot have x equals 90 because that's way more than 32. And then he says if y equals 1, then x plus 5 times 1 equals 90, which simplifies x is 85. This satisfies the total number of bills equation. So same mistake. Just to just to um just to confirm that he's made the same mistake again. Let's just scroll up and see where this mistake is. Where he picks y equals 1 and then gets x equals 85 and then concludes that it satisfies the total number of bills equation. Let's just scroll up. See, this is the same mistake that he made. Same mistake. And yet he apologizes for it. He says apologies. And then he comes to make the same mistake again. So this is quite an interesting development. Then it says, okay, therefore for z equals 1, one possible solution is x equals 85, y equals 1, z equals 1. This means you would have 85 $1 bills, one $5 bill, and one $10 bill in your wallet. And then he goes on. Now, let's consider the case where z is greater than 1. So here he's looking at z strictly greater than 1. So since we have a total of 32 bills and at least one $10 bill, the maximum number of $10 bills we can have is 3. Now, this is an interesting conclusion. It says $10 bills account for 30 units. This leaves us with 2 remaining bills to achieve a total of 32. So here he's completely lost, and the confusion is being caused by this. We know that x plus y plus z equals 32, and we know that x plus 5y plus 10z equals 100. These are the two equations we have to solve. But he seems to, this is for the total number of bills, and this is for the total value of those bills. Now he's saying that since we have a total of 32 bills and at least one $10 bill, the maximum number of $10 bills we can have is 3. So he seems to be using this equation to say that because of that equation, the maximum number of $10 bills we can have is 3. But that's not the equation he should be using to check that. This is the equation he should be using to check that. Okay, so he goes on. It says, let's check the remaining possibilities for z equals 2. We have x plus y plus 2 equals 32, which implies x plus y is 30. And then he goes on, which simplifies to that. It says, if we try different values for y, we find that there is no combination of x and y that satisfies both equations. Therefore, z equals 2 is not a valid solution. Then he goes on, for z equals 3, he says x plus y plus 3 equals 32, which implies that, correct? And then he goes on to get this. Again, after trying different values for y, we find that there is no combination of x and y that satisfies both equations. Therefore, z equals 3 is not a solution. Okay, it's not a valid solution. Good conclusion. It says, therefore, the only valid solution that satisfies the requirement of having at least one $10 bill and a total of 32 bills is this. Another surprising result, because you want 32 bills and yet you have 85 $1 bills. So it cannot be right. And yet he presents that as the final solution. So that is heartbreaking. Our friend Chat GPT wasn't able to resolve the issue. He wasn't able to solve the problem. And it was quite a surprise. I didn't think this was going to be a difficult problem for Chat GPT, but it seems it was. And even after multiple hints and many critiques on how to do things better, it still was not able to find the solution. Now, just to conclude the video, we've looked at this problem, we solved it completely in another video that I'm going to link to in the description. But let's just think about how a solution would look like. So we have these two equations, x plus y plus z equals 32. That's one equation. And then x plus 5y plus 10z equals 100. So this is the total number of bills equation, and this is the total value equation, as ChatGPT called it. Yes, we can try to do elimination. Let's do that. So let's call this equation 1, and let's call this one equation 2. So let's subtract equation 1 from equation 2. So we get 2 minus 1. What does that give us? Well, we subtract x, so x goes away. We subtract y, so we are left with 4y. We subtract z, we are left with 9z. We subtract 32 from 100, so we have 68. So after eliminating x from the second equation, we are left with 4y plus 9z equals 68. Now, the constraint which ChatGPT recognized correctly was that we need z to be greater than or equal to 1. We need at least one $10 bill. So how do we use that information? We can reason like ChatGPT was trying to do. You start with z equals 1, and then you see what happens when z equals 1. So let's see. when z equals 1, we have 4y plus 9 equals 68. That means that 4y equals 68 minus 9, which is 59. But because y must be an integer, we do not have a solution for this. For y to be an integer, we need this 59 to be a multiple of 4. So in general, if we notice or if you realize that from here we have 4y equals 68 minus 9z. To be able to get a value for y, we need whatever is on the right hand side here to be a multiple of 4. So what that tells us is that we need values for z for which 68 minus 9z is a multiple of 4. Now, because 9 itself is not a multiple of 4, um, we need z. We have quite a strong hint that it will be good for z itself to be a multiple of 4, because 68 is a multiple of 4. 68 is 4 times 17. So if we are subtracting something from it so that we want to end up with another multiple of 4, then that thing we are subtracting must be a multiple of 4. So that's the question we must ask. If z equals 1, do we have a multiple of 4? No. 1 times 9 is not a multiple of 4. When z is 2, do we have a multiple of 4? No. It's 9 times 2 is 18. When z is 3, do we have a multiple of 4? No. 9 times 3 is 27. When z is 4, do we have a multiple of 4? Yes. 9 times 4 is 36. So when z is 4, what do we have? We have 4y equals 68 minus 36, and that's equal to 32. That means that y equals 8. So when z is 4, we have y equals 8. And we can use those values of z and y to find a value for x using this equation. So z equals 4, y equals 8. So x equals what? X, we know that x equals 32 minus y minus z. So we have 32 minus 8 minus 4. And this is equal to 20. So x must be equal to 20 when z equals 4 and y equals 8. That means that we have 20 $1 bills, 8 $5 bills, and 4 $10 bills. Now let's see what the value is going to be. When you have 4 $10 bills, that's going to be $40. When you have 8 $5 bills, that's going to be another $40. And when you have 20 $1 bills, that's going to be $20. So 40 plus 40 plus 20, that's indeed $100. So that is one possible answer. Chat GPT didn't go far enough to get that answer for us. But let's see if we have another answer. And we'll see that no, we do not, because we can try with 5. 9 times 5 is 45. It's not a multiple of 4. Again, we are looking at this. Then we can try with 6. 9 times 6 is 54. It's not a multiple of 4. We can try with 7. 9, 7, 63. It's not a multiple of 4. 9 times 8, 72. It is a multiple of 4, but we cannot have that option because that gives us a negative number. So we know that any bigger number we choose is going to give us that situation where we have a negative number on the right. So we know that we have one unique solution, which is what we found here. Interesting problem.